Welcome back. In this section, we're going to be kind of ambitious, and we're going to talk about nothing less than how to become a computer programmer. Some of you are already programmers, and that's terrific. As you look through these videos, then you'll get a chance to see how JavaScript uniquely solves certain problems in programming. If you're not already a programmer, well, today's the day. It turns out that the basic ideas of programming are relatively straightforward, and there's not terribly many of them, and they work pretty much the same between all languages. So through the next 7 or 8 videos, we will learn all the basic ideas that you'll need in order to be a programmer of any style. And of course, we will take that knowledge and turn you into a game programmer. Pretty fun, huh? Yes, it is. It really is. So we're going to begin by looking at the foundation of all computer programming, which isn't programming at all, but data. So if you will, go with me to this type conversion page, and we'll take a little look first at this notion of data. Now, data is what the computer is working with. Computers are really about data. That's all they really do. And so what we're looking at here is how do we get the computer to do something more substantial with data than what we've done. We had a very simple version of it in that word story. We took in some text, we spat it back out. But as you'll see in this example, data is a little more complex and a little more compelling. Let's take a look at some examples on this page. I have 2 buttons here. One is add wrong, that frightens me, and the other one is add right. Well, let's click the add wrong button and see how a computer can add something the wrong way. It's asking for a number, x, let's make x 3. That's good. Oh, that's neat, a little pop-up. All right, we'll say okay. Now it asks for y, we'll make that 5. And it pops up an answer. 3 plus 5 is equal to 35. Oh boy, I thought computers were smart. Yeah, this doesn't seem right, does it? Yeah, something is not right there. Now, it turns out, of course, we can make it correct. Let's take a look at the Add Right button to see how that one works. We click on this one, and it asks the same process. X is 3, Y is 5, and we say 3 plus 5 is equal to 8. Awesome! Okay, that worked. That worked, but what's going on here? Well, something very interesting is happening. See, the computer works entirely in binary 1s and 0s. Now, we could go into all kinds of details about how that works. It's really fun. I've done it before. But we don't need to here. What we really need to understand is somehow the 1s and 0s in the computer memory have to be turned into stuff, like integers and real numbers and text and buttons and everything else, the robot zombie kittens that we'll make in our game or whatever. So somehow we have to convert from the very, very basic binary information the computer gets to the more interesting kinds of information that we work with in our programs. Well, to illustrate this a little bit farther, before we even worry about the code itself, I'm going to take a look at this console window. Now, again, if you're using Chrome, you should be fine. Some of the other browsers have this built in. I'm using Chrome, and it has this really neat console page. And what that does is it allows me to type in JavaScript in a little practice area, and it runs it right away. Check this out. Alert. Hi there. And it says hi there. So that's pretty cool, isn't it? Yeah, it's really neat. Now let's try some interesting things. I'm going to create a variable, var x gets 5. Okay, now print out x, and it's 5. No surprises. Now there's a really neat thing in JavaScript called the type of function. And what that does is I say, hey, what type of thing is x? Well, x is a number. Okay, that was really clever. Now, if you're used to programming in other languages, you might say, well, what kind of number? Is it an integer? Is it a floating point? In JavaScript, we don't care. It's just a number. We can get more specific, but we're not going to worry about that yet. Okay, that's fine. That's fine. Okay, how about this? Var x gets Andy. Okay, we'll print out x, and it does. Now, notice when it prints out x, it's in quotes. And also, if I do that type of, it says that's a string. String? Okay, computer languages don't usually call text text, they call them strings. And that's because the way that strings are stored in memory reminded the early programmers of beads on a string. And if you take a language like C, well, you'll see that at work. We actually still think of things that way. It's fine, you just want to sound fancy we never say text as a programmer, we say string. You good? Yeah, I'm good. Okay. So X is a string. That means it's text. Okay, now we have seen this before. Let's say we have Y gets Harris. Okay, and then we say X plus Y. Andy Harris. Now, we saw that before, didn't we? When we were bringing stuff in from the form for the word story game, we would bring in variables, and all of our variables were text. They were strings, and we used the plus sign to combine those things, right? Yeah, but that wasn't really adding, was it? Adding doesn't really make sense in the string context because you don't add strings, you add numbers. Okay, something else interesting. Okay, let's try it again. X gets 5, Y gets 3, and we'll do the same thing. X plus Y, 8. Huh? How come now X plus Y gives me 8, and before it combined things together? Okay, one more thing. Watch this. X gets quote 5. Y gets quote 3. X plus Y. 53. Aha. You starting to see it? Here's what's happening. See, in JavaScript, we don't ever have to say exactly what type of information is in a variable. The computer will guess. But you know what happens when you guess too much, right? If we trust computers too much, we know what happens. Check any science fiction movie for this. So we shouldn't always trust the computer. Now, here's what's happening. If I put 5 in quotes, it says, oh, that's a string. That's text. If I don't put it in quotes, it's a number. So the question is, when I pop up this dialog and ask for a value, is it reading this as text or as a number? Aha, it is reading it as text. Most input and output to the user is read as text strings in most programming languages. And then if you want it to be something else, you have to convert it. Aha. Yeah, I know. There's languages that allow you to read stuff in directly to a term. But I'm going to say in a graphic user environment system like this, then most input and output to the user is in strings, and it has to be converted to what you want. Does that make sense? Okay, I'm going to close up this console. I'm going to look at the source code and see exactly what's happening. Why does one of these things not work correctly and the other does? So we'll look at the code, and you can see it's relatively straightforward. As usual, we start with the HTML, which is very straightforward. We have 2 buttons. Each button has its own function. So can we have more than one button? Apparently. And can we have more than one function? Apparently. All right, that's all easy. Now we look up at the script. There's one more thing that might confuse you on the script. That's this line 9 and correspondingly line 33. Now, actually, you don't need to worry about this at all. The cheap version is this. In previous versions of HTML, you had to do a little bit of special coding to tell the browser, hey, this is not HTML code. Don't worry about it. Don't try and treat it as HTML. And that's what this nasty CData thing does for us. So I still have that around because I still have some code written in XHTML. But it's really not necessary anymore in HTML5, so feel free to leave that out. You'll see it's still in a few of my programs, but most of the later ones will take it on out. So you don't really need line 9 or 33. It's not going to hurt anything, but you don't really need it. Okay, now we take a look at our 2 functions. First we do add wrong, which makes plenty of sense, except of course it doesn't work. All right, so what does it do? Well, I could read the comment. It inputs 2 numbers. Gosh, we love comments. Yes, we do. All right, so we input 2 numbers. Take a look at line 13. Var x gets prompt y. Now remember that gets is about assignment, not equality. Right? We're just saying x is going to get some value. We're going to be talking about equality in the next video or 2, but right now we're still talking about assignment. Prompt is a special new command. That's the one that pops up that dialog that has a little typey anything. Okay, so it says x, and then it waits for the user to type something, and whatever the user types gets stored into the variable x. Okay, we get that. Now this line is just the same. Now what you and I know right now is that what type of data is going into x and y? String. So line 15 says var sum gets x plus y. It's taking x and it's adding it to y. But since x is a string and y is a string, what kind of adding is it doing? Oh, it's doing the special kind of string adding, which isn't called adding at all. It's called concatenation. Don't we love complicated word for easy ideas? So it just says, hey, take these two strings, munch them together, and make them one. And I guess that is kind of what the plus sign ought to do in the context of strings. So this is the one that's going to give us 5, 3, because it's too stupid to know that x is a number and y is a number. Okay, take a look at the alert. It looks a little crazy, but you got to squint a little bit and figure out where the quotes are. That is the value of the variable x. Combine it or concatenate it with space plus space. Combine that with the value of the variable y. Combine that with space, quote, space. Combine that with the value of the variable sum and alert that whole thing out. Okay, that's pretty straightforward, but of course it won't work the way we intended. It's too stupid to know that x and y ought to be read as numbers. So take a look at add right and see what we do to fix things. It starts out the same, it ends the same. Notice the line that seems to break is exactly the same. It's exactly the same. What's different is lines 24 through 26. The parseInt command allows us to take a variable and say, henceforth thy shall be known as an integer. ParseInt says, hey x, turn into an integer. It'll do its best to turn into an integer. And we'll assign it back to x. Likewise, line 26 says, parseInt, take y and convert it to an integer. You remember integers, right? They're 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on. So they're the whole numbers and 0 and negative numbers. You thought you'd never need that for math class, did you? Yeah, we use it a lot because they're stored differently in memory than real numbers. There's also a parse float. Programmers don't normally say real, they say float because the form of real numbers we do is called a floating point representation. So there's also a parse float command that we sometimes use. There's also a toString function that we sometimes use, but honestly it's not used very often because most of the time the default is string, so it's not that necessary. Don't worry about memorizing this stuff. When you need it, you can Google it. It's not a big deal. It's not something that happens very often. But in some of the games that we're going to be doing coming up, we are going to be asking the user for numeric input, so it's nice to know how to do it. Okay, if we ask them for input, it'll probably be in a string. We want it to be an integer. Fine, we'll make it one. Now we look at line 28, and what's interesting is that even though this line looks exactly like line 15, it turns out to have different meaning. Sum is the same, x is the same, y is the same, but what's different is this plus sign. Because it says, well, x is a number, y is a number, I should add them. In this one it says, x is a string, y is a string, I should concatenate. We could talk about fancy computer science ideas like overloaded operators and so on, but let's not. You know, strictly typed languages, that sort of stuff. I know a guy who teaches those classes and he's boring. So let's just go with understanding the idea. Hey, if it doesn't do what we want, we should check what type of data we're dealing with and make appropriate conversions. Now, line 29 is exactly what you already knew. It works exactly right. This is pretty cool, isn't it? Yes, it's very cool. Okay, come back next time and we will learn how you can make a computer appear to make decisions. That's pretty powerful stuff. All right, I'll see you then. Take care.